And my colleague also on the call here is Johan Nel, and you can reach me at this email address, or you can reach us at support@ixusapp.com, as I believe most of you guys should know. Now, I just want to take a minute to mention that for the attendees, there's quite a few names that I recognize, but that's not that might be very new clients. So this is more intended towards folk that's already got IXUS, has some experience in IXUS, and we only focus on the updates that has been released now. But obviously anybody's can ask any question. Okay, so firstly, those of you subscribed to our user base is aware of the release email that we sent, I think last week. This release was provided on the 26th of April, and it's entitled IXUS 2022.1, but the underlying modeler and manager versions are shown over here. So please make sure that you read that email thoroughly, especially the update or installation instructions that's available on our help desk. And also there's a change log attached to that email. So again, if you don't follow everything now in this talk, just reference that, and you should also see everything that I'm showing you now here. Okay, so just to go through the list very quickly of all the things that we focused on for this quarter's release. We looked a bit at the concept of or extended our concept of spatial averaging. So as most of you should know, the spatial averaging options has been allowed for the exclusion zone. This is this 3D plume. So for my USA friends, I know this is something that is quite new there, but this is a 3D shape of how the antenna or the RF safety zone. So we've had spatial averaging on this zone since last year's release. And then we also introduced spatial averaging for the environmental slice, which is a 2D plane, but only for a particular case. So we've extended that now in this release to account also for different spatial averaging schemes that I'll show you a bit later in the slide. Then one of the things that that users also requested that we implemented is the fact that you really want to quickly determine what is this minimum separation distance between a surface and an exclusion zone, and we've added an option to our lobe height tool that simplifies that for users quite significantly. We've also enhanced the way in the data, the metadata that's associated with lobe imprints. So I will show you a bit later the lobe imprint tool also, and how it now keeps track of at which height this imprint was performed. And then we've moved things around a little bit to make things more intuitive, specifically our calculation settings. We've updated our UI for that. Also in that widget, we now show the power level adjustments. So power level adjustments comes into play when you activate uncertainty calculations in your simulation. So there's quite a few uncertainty estimate calculations, and that effectively leads to some form of a power factor adjustment, right? And we just show that now here in the modeler as well. In previous releases, in the previous release, it was available in the manager, and we just pulled it through to the modeler now. Something that was inspired by users making use of discrete environmental slices is the fact that not all discrete environmental slice buckets or color groupings are according to their choice. So we just added an easy way for people to customize this now in our ini or settings file. And then we've added some smaller but important improvements. We've updated the default values of some of the shapes like ladders and railings. Something that we worked on and that we are continually working on is this speed improvement for environmental slices, especially when these slices makes use of spatial averaging. And then in addition to all these enhancements and features, we've also addressed numerous bug fixes and smaller type of things. Okay, so firstly, I'm going to go through these features, some of which will be in the slides and other will be, I will demo in the modeler. So the first one is, exclusion zone. How we've pulled through the exclusion zone spatial averaging options to the environmental slice and also the field point. So I'm going to focus on the environmental slice here, but the field point works exactly the same. So here on the top right, I list here the current spatial averaging calculation schemes that is applicable for exclusion zones or for plumes. Now, none obviously means no spatial averaging. This is just a point calculation. So field is evaluated at a particular point. And then there's the others, like over a 2 meter range, give me 3 samples, that's 1 meter spaced apart. Or 3-point IEC scheme, which is documented in the IEC 62232 standard, and also a 5-point scheme. So users have requested that these options also be made available to the environmental slices. So over here in the middle, I show you an environmental slice. And then if we apply now, in this case, spatial averaging, and you will note that this changed a little bit. If we apply here and select the 3.0.6 meter IEC spatial averaging range, then effectively what it will do is it will, for each point on this environmental slice plane, right, it will calculate the field at 0.2 meters above it and 0.4 meters below it, and then return the value on that particular plane. And this is in line with the IEC 62232 standard. And the same convention also follows for the other exclusion zone type calculations, which is now just exposed here for the environmental slice also. Then a lot of you guys have already been using spatial averaging with these slices. And that functionality remains intact. It is only now accessible via the custom option. So for the environmental slice, you select the custom option and you specify your vertical spacing that you would require. And then it is applied to this particular range. So if this environmental slice is associated here at let's say 1.5 meters, and you select this spatial averaging scheme, then it'll place samples as I show here with these little dots and return the average value here on the plane height. So for the people used to imperial units, we also have in our modeler a very simple setting to change everything to imperial units. But as you can hear, I'm not very fluent in that. So yeah, please, I apologize for that. Okay, now for the lobe heights, this I would actually like to show you using the modeler. Okay, so let me first. I'm not going to simulate something now. I already simulated this site, got a simple antenna here, and then we generate the 3D zone. So now what you can do is people typically want to know that if we have a surface over here, what is the height between the surface and any part that touches this lobe? So obviously this yellow region is an occupational standard, is an occupational, public hazard zone according to some safety standard. Now this could be FCC or ICNIRP or whatever, right? But we want to know where is it safe, predominantly where is it safe to walk on here? And this minimum separation distance or the separation distance typically indicates that. Okay, so in previous versions of the modeler, what was available is if you had to select a particular point below this plume or exclusion zone, and then you can calculate what is the distance between the surface and this exclusion zone. So here we go. Here I already see the settings is in feet. So okay, but this is difficult because it relies on the user to go and look for these points and according to the adjustment. So what we've added now is, let me just get rid of that. What we've added is the ability we've added an algorithm to calculate that minimum distance automatically, and it's done by this area option on the exclusion height. So you just select the area, and then you define the area according to 2 points. So we have a point over there, and we have a point over there, and then we say, all right. Oh, I ran into this exact user error, and it's not an error in the tool, it's merely an error by me not using it regularly. So let me just try that again. Select our area. It's my first corner, my second corner, and there we go. Okay. So now you see that I automatically, using that functionality, was able to determine that the minimum distance below this exclusion zone here, or plume, is located at that particular point there, and it is this value. Okay, so if a person taller than 2.84 feet were to walk here, his head would touch that particular point. Okay. The other feature that I think is good to highlight here is this lobe imprint height selection improvements. So most of you should be familiar with the concept of a lobe imprint. Lobe imprint basically asks the question that if I were a human walking around here, project all the points of this 3D exclusion zone onto the surface on which this person is standing. So it's a very easy way to visualize which points are hazardous. Now, obviously, that determines on the height of the object that is moving through the zone. So here, for example, this person is, let's say, 6 foot. Okay, so let's ask then, give me all the points that's above 6 foot that this person's head will be exposed to. So if you go and you calculate this, then you will see that you have this region that's projected onto the surface. So apologies if I explain this now to a lot of users that already know it. I'm just doing so for the benefit of people not used to this. Okay, so all right, so now we've got our lobe imprint here, but as current users will confirm, it's very difficult now to see if you have multiple lobe imprints, at what heights were they done. So now you can easily do so by just hovering over the lobe imprint here in the tree view, as I show on the left. You see that this lobe imprint was done at 6 foot. Calculation settings, update and power level adjustment values I'll show together. So this is just now, you will remember this button just opens the execution of the field assessment calculation. So what we have done is we have made it easier and more summarized for users to see exactly which simulation settings were used. It's listed here on the widget, and you can edit those by just clicking edit. And then you can select your safety standard, you can add a custom exclusion zone, you can change the spatial averaging here for the 3D exclusion zone. That's independent of the environmental slice and also the field point widgets. And then you can also specify your confidence level. So if you want to include an upper two-sided 80% confidence interval, then you just click on this, it's activated, and here at the bottom, we also show you what is the effective power level adjustment. And you can then add things like scattering and reflection and so on. And then you just press simulate, and the simulation runs, and you have the results. Okay, customizable colors for discrete environmental slices. What we have done, this is a first iteration implementation, and we know that we would like to make updating defaults and preferences for users in the future a little bit easier. But at the moment, because this might not be something that you change so regularly, we have reverted the settings for these colors, these buckets as we call it, to this file, the ini file, which is located in a particular directory that's created when IXUS is installed. So what you would do is you would close your modeler, you would then open that file, and you will, just for a particular bucket, enter the hex value. It's a hex color code. It's very easy to get off of the internet or of any, basically any reference. FFF, all that is white, but this is very easily to obtain. So you can see whatever color you would require, add it here, open your modeler, and then new slices that you create or new buckets will be updated with these colors. Now, this is just an example. That's not probably a practical example, but nonetheless, it illustrates the point. Okay, we've also updated some defaults of basic shapes. So we have a railing that is, here we go, this is the railing. It was 1.5 meters, but that's pretty tall railing. So we've updated the default to go to 1 meters. But again, we can change it to feet, and you guys can change all the settings yourself. This is just now what happens when you add this. It'll have this default, but it can be edited. And then same thing for the ladder offset. It was changed from 0.3 meters to 0.2 meters, and also for a pole, just the radius. Okay, and the final two things worth noting, I already said that, is we've done a few bug fixes and also some speed improvements for our environmental slice calculations. Those are the big things. But something that I really urge you to do, and something that I think is central to our philosophy at IXUS, is we really want to support everybody, all our users, as best possible as we can. We have different channels for that. We have an email channel, so you can just email us at support@ixusapp.com. You can log, for existing users, you can log a support ticket via our help desk. So you can just go to this link and then log a ticket. We also use this for antenna requests. So if you guys request an antenna, just add it to the help desk, and our team will attend to that. And then finally, you can schedule a call with us. So we prefer to use this platform called Calendly. You can just visit this link, and if it's an upgrade assistance, schedule it in that compartment, or if it's just a general support, or I think we also have a demo function there, so that you can use. And then we'll have one of us will attend to that call. And then finally, our tools development, IXUS's development, is really influenced by what you guys need and want. So, the way in which we can't attend to everybody's needs at the same time is very difficult. So we have on our help desk this section called the feature request section in the knowledge base. And here you can create a ticket and say that, like, for example, field points should distinguish between frequency bands and antennas. It's a feature. You can flesh it out a little bit with the description, and then people can vote on it. Other users can see this is a nice feature to have and vote on it. And finally, we take this in combination with discussions that we have with our users during support calls to make sure that we really aim our development at something sensible and not just sit and think what the market might want. So this is just something that I want to mention as well. And thank you very much. I hope it was interesting for you, and please feel free to ask some questions.